We got two examples. We got two examples going on here. We got a number of people gone today, right? Should we put a keyword into the video to see if people are actually watching it? Like, who do you think out of this group will actually watch it first? Which one do you think will watch it first? You're going to say Abby? We'll test. We'll say, you think Lauren? Okay, you think Lauren? All right. So how about this? Somebody come up with a keyword, a word that nobody would expect.
No, those are too basic. They're too basic.
Alfredo in a math class? Okay. Alfredo is the word. Nobody tell them. Yes.
It's not. Yeah, that's
Okay, then what is it, B-Jack? Come up with one. What? D's? How do you spell it? D-E-E-Z?
yeah.
All right. The word is D's. And it's got to be sent to me in an email. And if you send it to me in an email, I will give you your choice of a Star Crunch or an oatmeal cream pie. There you go. So, no, you can't. You be quiet. No, here's the deal. There's two words. It's D's and Alfredo. Got to have both of them. There, take that. If you guys dare tell them I am, this next says you're all just going to, yeah, it's going to be horrible. So, all right. So don't tell them. No, it's a threat and a promise. It's a promise. Alfredo and D's. Here we go. Don't tell them. We'll see who gets it first. Okay, I'm tired of doing boring stuff. Let's do exciting stuff. I've got the graph of x to the fourth and y equals 2x squared minus 1. And what I want to do is I want to find the area bounded between those two curves. And here's what I know about the graph of x to the fourth comparatively to the graph of x squared. X to the fourth is a little bit kind of flatter at the bottom, okay? I'm going to kind of exaggerate it there. And then 2x squared minus 1, that's shifted down 1 unit, isn't it? And it turns out that it just kind of, well, I didn't do a very good job of that. We'll try again. That's better. Yeah, you have two graphs. Yep. So they kind of just touch right on the sides. Okay? I'm going to orient my smartboard and try to do a better job here. Tangential, thank you. Okay, I'll try one more time, try to make it nice and clean. Okay, not too bad. All right, so which graph is on the top? X to the fourth. What's on the bottom? So, and if you were to draw a rectangle to represent the area, if I draw one rectangle, notice that I draw from the top to the bottom. Does it have horizontal thickness or vertical thickness? Horizontal width, right? So it's a width of dx. So therefore, the area of one of those rectangles will be dx, the width, times the height. And the height is x to the fourth minus 2x squared plus 1. Why did I write x to the fourth minus 2x squared plus 1? Yeah, when you subtract, and make sure you distribute that subtraction sign, okay? All right, that's the area of 1. I want an infinite number. How do I get an infinite number? Slap on the integral, okay? There we go. What am I missing? Bounds. Now, in order to get the bounds, I want to know the intersection. Agreed? So I want to find the intersection between these two graphs. So I'm going to set them equal to each other. And I have 2x squared minus 1 That's going to be equal to x to the fourth. How would we go about solving an equation like that? Yep, we'll get everything equal to 0. 0 equals x to the fourth minus 2x squared plus 1. Now what, you super smart kids? Factor, so I got 0 equals, I'm going x squared and x squared. Minus 1, minus 1. So, yeah, plus and minus 1 and plus and minus 1. Yeah, 4 solutions, but it only like intersects twice, doesn't it? And it means that it touches tangent, as you were saying before. So this intersection point there is at an x value of -1, and this intersection point there is an x value of +1. And so now I'm going to teach you something that saves me time, and most people understand it. However, some people choose not to do what I'm going to do right now. And here's what I'm going to do. I'm going to take this integral, and I'm going to go from -1 to 1. I recognize by my drawing that the area on the left-hand side is symmetrical to the area on the right, or the area on the right-hand side is symmetrical to the area on the left-hand side. Do you agree? So instead of going from -1 to 1, I'm going to go from 0 to 1 and just double it. You will get the same answer. I'm more likely to make a mistake when I plug in -1. I'm less likely to make a mistake when I plug in 0. Get my point? So that's a strategy that comes up later on as we continue to progress. Just understand that everything I'm trying to teach you, we're building off of for future things. But I like that option. And there's at least one problem in your homework where you can do the same thing. Where I choose to say, you know what? Just because you see -1 to 1 doesn't mean that you could double it. You have to see that the graph is symmetrical. See what I'm saying? And once you notice that, you can say, okay, we'll go from 0 to 1 and we'll double it. It's a nice little trick. And now this becomes a very easy problem. You just take 2 times, what's the antiderivative? Minus 2x to the third over 3 plus x. And we're going to determine the area from 0 to 1. And you can see in this situation, we plug in 0, you do get 0, correct? But if we plug in 1, we get 2 times 1/5 minus 2/3 plus 1. And I can make this a really clean result. What should my denominators be? 15. So I will have 2 times 3/15 minus 10/15 plus 15/15. And as we combine our fractions, 3 minus 10 is -7. -7 plus 15 is 8 times 2 is 16/15. That's the exact area bounded between those two functions. It's kind of cool. Complicated problem, we make it simple. So far, has our thickness ever been something other than dx? No. You are now going to see thickness of dy. This is our last problem, then we're going to go. High five, Beach. Yep, high five. There we go. Yeah, all right. Nico, where's the birthday party? I did not get an invitation. Anybody else? I was not invited. You were not invited. You weren't invited. She wasn't invited. Interesting. Raiden, you weren't either. All right. Okay. Oh. Boo. Unbelievable. How some people get in, I don't know. All right, here we go. Find the area bounded between y equals 2x minus 2 and x equals y squared minus y. Look, take 25 seconds, talk to each other. What makes this one different than the others? Go. 5, 4, 3, 2, 1. What makes this one unique and different? Yeah, did we talk about that last year? I can't remember. Did we do parabolas and hyperbolas and ellipses?
Yeah.
We did. So this makes a parabola, but instead of being up and down, it's a sideways one, isn't it? And actually, I can learn a lot about this graph. If I just factor it to be y times y minus 1, it turns out it intersects the y-axis at 0 and 1. So it intersects the y-axis at 0 and 1. So that means that it's going to intersect here, it's going to intersect here. So as I draw this parabola, I get something that's about that shape. We okay with that? Not too bad. It's positive y squared, so I knew it's going to go to the right as opposed to the left. And then I have y equals 2x minus 2. Well, that's easy peasy, right? Like 2x minus 2, like we've done that lots of times. So I'm going to go down 2 units. And I'm going to, kind of draw my graph there. I want to find the area bounded between those two. Are we okay with that? Okay, so let's identify then the problem at hand. We talked about drawing those triangles, and look at this, or those rectangles. If I draw the rectangles, which one's on top, the parabola or the line? Parabola, and then the bottom one is the line, right? But notice that if I just move my shape a little bit, what's on top? What's on bottom? And so if you do top minus bottom, see how that's an issue? Like it's going to go away. So let's not draw top to bottom. Instead, let's draw this way. Notice how if you draw a sideways rectangle, that it will always, you will always have the line on the right side, and you will always have the parabola on the left side, don't we? So this is where we start. Look at the shape that's drawn. That rectangle that you drew, does it have thickness that is horizontal or thickness that is vertical? So therefore, it has thickness of dy. That's the most important step in the problem because it tells us that instead of our variables being x, all of our variables need to be y at this point. So dy, and then instead of doing top minus bottom, you do right minus left. So what's on the right-hand side? The line, right? So you would say y equals 2x minus 2. But notice how it uses the variable of x? We need it to use the variable of y. Okay? Because notice the thing that's on the left. The thing that's on the left is y squared minus y. Agreed? You can't have 2x minus 2 and then subtract y squared minus y. You have to have all y's. So let's rewrite this one up here. How can I rewrite this so it has a variable of y instead of a variable of x? Okay, exactly. I see what you're saying, and we will do that in a second. But before we do that piece, all I'm going to do is just solve for x. I'll have a y plus 2 is equal to 2x, and then I'll divide by 2. So we get a 1/2 y plus 1. So that's the function that's on the right. See how this is an x equals with y's? Now this is an x equals with y's as well. So let's get to your point that you made here in just a second. But first we'll take the right minus the left. Okay? So if I take the right and I subtract the left, what are you going to get? Yeah, 1/2 y minus negative y. What's that going to give me? 3/2 y. And then I'll have a plus 1. And that will be a positive y squared or negative y squared? Negative y squared. That's the area of that one rectangle. We want an infinite number of rectangles, so we slap on the integral. And now what do we need? We need our bounds. And it turns out that our bounds are going to not be x values. Our bounds will be y values. So we're looking for that spot, and we're looking for that spot, which is the intersection between the two graphs. And we can find the intersection of the two graphs by doing what was it you, Lauren, who said it? The sound was coming from over this area. Okay, so Freddie spoke up and she said, if we want to find the intersection, what we'll do is we'll take x equals this thing and we'll dump it right in there. And she's right. That will allow us to solve for the intersection via substitution. And so we get y is equal to 2 times y squared minus y. And then we have minus 2. Or y is equal to 2y squared minus 2y minus 2. Kind of pretty. Subtract my y. 0 equals 2y squared minus 3y minus 2. Is that a factor? To what? To y and y. Is it going to be a minus 1 plus 2 or minus 2 plus 1? What am I going to have? Yeah, that's going to give me my negative 3, isn't it? So therefore, what are my solutions there? Let us look back at our drawing. Does it appear that the intersection points happen at about negative 1/2 and at about positive 2? Yeah, it would seem reasonable, wouldn't it? So I'm just trying to verify and check my work. So we've got a negative 1/2, we have a positive 2. So the integral is now set up. Let's go through the process of solving it. And that will be that. A little bit more involved. Antiderivative of 3/2 y. Yeah, 3y squared over 4. Carter concurs. Plus y minus y cubed over 3. Evaluated at 2 and negative 1/2. Uh-oh, we've got a fraction. Fortunately, we are excellent with fractions. Somebody just vomited in class. Okay. Probably that over. It's the Alfredo. Did you guys have that for lunch today? Was that the deal?
No.
Okay, my kids, we had sausage Alfredo last night. So, all right, we plug in 2. 2 squared? 4. Divide by 4? Times 3 is 3. Plus dos, which is Spanish for 2. Plug in the 2. We got, let's see, 8 over 3, so minus 8/3. Minus, now I got the dreaded fraction, negative 1/2 squared. Positive 1/4 times 3, 3/4. 3/4 divided by 4, 3/16. Negative 1/2, so minus 1/2. Yeah, and then negative 1/2 cubed is negative 1/8 divided by 3 is negative 1/24, so plus 1/24. Common denominator, I'm going 48. Anybody else? 48? 48, okay. So 3 plus 2 is 5. If we turn that into 48ths, 240. Minus 48, so we got 16. 8 times 16, 128. Most people would get out their calculator by this point.
You are.
Minus, it looks like we're going to have a 9er over 16, plus 24 over 48. Because I'm an idiot. Minus 3, no, 9 for 48. And then minus those over 48. And we add them up. 240 minus 128. Yep, 112 minus 9. 103 minus 2. 101 plus 24. 125 over 48. That's the exact area. Yep. So you should be ready for the rest of your homework at this point. Notice that you do not have school on Monday. So you do have 3 days to kind of get caught up on this. So please come to class prepared on Wednesday or Tuesday to either A, ask some questions, or B, be ready to move on to the next piece.